The rest of 4.2 talks about natural log. On your calculator, do you see where it says LN?
1 second.
Okay.
Just trying to make sure you get all my stuff down.
Yeah.
Okay. The LN is, this is still 4.2. The LN is called natural log, okay? If I press the second button in the LN, you get that e to the x, okay? E is the base of the natural log. So if you see LN written like this, its natural base is e. They go together, okay? Just like when I have log, the natural base is 10, okay? So the natural base of LN is e, okay? You cannot do this type of work without a calculator, period, because you can't raise e to a power. Like you can raise 10 to the first or 10 squared in your head. You can do that type of stuff. But you can't do e to a power because e is like 2.53, blah, blah, blah. It's a big decimal number, okay? So we're going to use properties of logarithmic functions and apply them to natural log as well. So you're going to start with simple things like if you have ln of x, and then you're going to start with things like we did the other day. If x equals 2, what's your answer? If x equals, I don't know, let me give you a decimal, 0.3, what is your answer? If x equals -1, and then let's throw in a radical. If x equals 1 plus radical 2. Okay. So let's solve all of these with our calculators. So for this one, you're just literally pressing the LN button, and then you're doing parentheses and whatever your number is. So when you put in LN parentheses 2, what do you get out?
0.69.
Beautiful, 0.69. When you plug in LN and then parentheses 0.3, what do you get out?
What's the answer?
When you plug in LN 0.3?
I got
Negative
yeah.
1.2.
Yeah, you get -1.2. -1.2. Okay. What happens when you plug in LN and then -1?
Nothing.
Error. Yes, error. It should not work. Okay, I can't plug in a -1. What happens when you plug in LN and parentheses 1 plus radical 2?
0.88.
Beautiful. 0.88. Okay.
Oh yeah.
So that's the first part of what you're doing on tonight's homework. You're going to get numbers, you're going to plug them in to your calculators. You should be able to get answers out pretty simply. Okay? From there, we're then just going to apply those natural log rules. Okay? Remember how we had the logarithmic rules where it said, like, if something's raised to the 0, it equals 1. If we're going to apply the same rules. If I have natural log, there are 4 properties to this one as well. So if I have, the first one is, if I have natural log of 1, okay? Natural log of 1 is going to equal 0 because e to the 0 equals 1. Ln and e are interchangeable. Do not forget that. So when I'm changing something, like when I had log base 2 of 5 equals 7 or whatever it was, you know, we always took 2, we raised it to the 7th and set it equal to 5, right? Okay? This, you have to remember that there's an e there. You're taking e, raising it to the 0, setting it equal to 1. Okay? So you have to realize that there's an imaginary e there. The second rule tells me if I have ln of e equals 1, that means I have e to the first power equals e. Because remember, there's a little e here. So e to the first power equals e. This is still what we talked about. Base, your a, your x, your y. Your a, your x, your y. The third rule, ln e to the x equals x. Okay? ln e to the x equals is the same as saying e to the ln of x, okay? E raised to the ln of x equals x. And then the fourth rule, which we went over as well with logarithmic functions, is if ln x equals ln y, then what happens? X equals y. Okay, so we're literally taking the same exact 4 rules that we took with base of 10 and applying them to natural log. That's why I said we're going to go through everything today, because it's the same stuff we wrote down the other day. Okay, now, using properties of natural logarithmics to rewrite each expression. So let's rewrite all of these. Let's say I have ln 1 over e. B is going to be e ln of 5. C is going to be 4 ln 1. And D is going to be 2 ln of e. Okay. How do I rewrite the first one? ln 1 over e. How do you rewrite that?
Would it be e to the first power equals e?
E to the what?
First power equals e?
Okay. It is e to the negative 1 because I have a fraction. I have to make it a negative exponent, okay? So it's ln e to the negative 1, okay? So if I rewrite it, I would rewrite it as ln e to the negative 1, which means my answer comes out to be negative 1, okay?
How did you know how to do that?
How did I know how to do what? To change it around? This, remember, this has an imaginary base of e, okay? So if I have 1 over e, I've got to get this up top. To get that up top, you have to use a negative exponent. Anytime I'm switching something in a fraction, I use a negative exponent. Or if I have a negative exponent, I use a fraction to switch it, okay?
How'd you know to use rule 3 though? Is that what rule you used or no?
No. Well, it's kind of like this rule here. It's this rule, but it's in fraction form, which is why I get that negative 1. So here's what happens. There's an imaginary e here, right? And there's an imaginary e here. So if I flip this so that the e is up top, I have to make my power negative. What then happens is, because this is natural log of e to the e, this cancels out, leaving you with negative 1. This one's harder to see because there's no, because the e is missing and not visible there.
Does this look more like rule 3?
Well,
I don't know.
I didn't raise the base to the power. I didn't change that around. I changed the actual unit around, not the power, not the base around. This one is like this. See, I have e to the ln of 5. Okay, so I have e to the ln of 5. So if I want to rewrite that one, how do you, or if I want to solve that one, what does it equal? It equals what? Why is it equal 5, Lindsay? Yeah, because right here, this is e to the ln of x. It equals whatever that is. So it equals
That
x.
makes sense.
That one makes sense?
Yeah,
Okay, good.
the first one did.
Because it's a fraction. That's why. Okay, what if I have 4 ln of 1? 4 natural log of 1. How can I write that or change that around? Okay, look here. Look at this portion here, right here. What does it match with up there?
Number 1.
Number 1. So I got property 1 going on, which means what is my answer going to come out to be? 0. Okay? It's not in this form. It's in this form.
Oh, okay.
Okay?
Those are two separate things.
Okay?
I didn't know they were separate things.
Well, they are and they aren't. I can change them around to manipulate to be whichever one I need it to be at the time. Okay? They're interchangeable. They're interchangeable. So what this is saying here, if I change this, it's saying this. It's saying I take this 4 that's out in front, because right now this is saying 4 times ln of 1. ln of 1 equals 0. So I have 4 times 0, which is going to equal 0. Okay? I'm replacing this ln of 1 with that 0 so I can solve. If you plugged it in your calculator and you press 4 and then you press ln and then you press parentheses 1, you're going to get 0 out.
Whoa.
Okay? This is just taking what this rule told me. I have ln and I have I have ln and 1 as my x. That always is going to give me 0. So if anything is being multiplied out in front of it, it's going to multiply by 0. Doesn't matter what this number is. I want to focus on what this stuff is right here. Okay, what these are. So over here, I have this, right? What does that match with? Anything up there? ln base of e. 2. So what can I replace ln base of e with? 1. So essentially I have 2 times 1, which gives me what? 2. That's what you're looking for. You're looking to replace it with those numbers so that you can solve. Okay? Okay. The first one is because it cancels itself out, Dakota. Because this imaginary e is there, this can cancel itself out, leaving you with just a negative 1.
Oh.
That's why that happens.
Okay.
Okay? So it just cancels itself out. Let's talk about graphing these functions. If you want to graph f of x equals ln x minus 2. Okay? That means that this graph, compared to the parent function, is doing what? If it's with the x, it's going right. It's going right 2 units, okay? Because it's with the x. So, if you're graphing these, I suggest you pull out your graphing calculator and that you plug in ln and then parentheses x minus 2. And you press graph. You should be able to graph it in a standard window set. Okay, and so your graph, instead of coming from here, right? What is your standard window?
Yeah.
Standard window is negative 10, 10, 1, negative 10, 10, 1. So instead of this graph going like this and never crossing here and just continuing to grow this way, it's going to shift over 2 units. So your new asymptote becomes that 2. Okay, it tells me so right here. And this graph is going to come, and it's basically going like this, right? Okay, so what is your domain of that graph? What is your domain? Your domain also comes from here.
Negative 2.
Not negative.
2.
What do you mean 2? You have to give me more specific instructions on domain. X is,
Infinity or whatever. Will,
oh, okay, we can write it that way. We could say from 2 to infinity,
yeah, we know.
but you have to use parentheses because it never crosses 2. It never touches 2. If it touched 2, I would use a bracket if it was my cutoff spot and it touches it.
You also say all real numbers is
You could say, that's another way you could write it. You could say, well, no, you would say all positive real numbers except for 2. And then another way you could say it is, you could write it as x is greater than or equal to 2. Okay, so any of those are acceptable. Okay, what happens if you're graphing, I'm sorry, not greater than or equal, it's just greater than because it doesn't touch x, or it doesn't touch 2. What happens if you're graphing ln x squared like that? Okay, put that in your calculator and let's talk about domain on this one. So like I said, tonight's homework is going to be all using your calculator because you can't do this by hand. It does, Lindsay. It goes like this. One graph goes this way, and one graph goes like this, right? So what is it not touching? 0. So this one is all real numbers except for 0. So you can write it that way, all real numbers except for 0. X squared is, greater than 0. It's all real numbers except for 0. And that's the best way to write that one. Or you can write this one again in notation form where it's like this. Okay, you can write it that way in notation form. So what it's saying is negative infinity to 0 and then 0 to positive infinity. You can write it either way. Okay. Those are the things you're working on your homework tonight. Okay. So let's get this done with.